Welcome! I'm so glad you could join us as we continue our series on the Georgia Early Learning and Development Standards, or our GELDS. Today our topic is science under the cognitive development domain. My name is Laura Evans. I'm the Standards Coordinator at Bright from the Start, Georgia Department of Early Care and Learning. And once again, I am very fortunate to have with me a special guest, Dr. Laura Johns. Dr. Laura is our Director of Quality Initiatives at Bright from the Start. Dr. Laura and I are going to walk you through the science subdomain and go over some of the strands, standards, and age-appropriate indicators that you can expect with the GELDS rollout. We will also share some teaching strategies and activities for how to address this domain with children from birth to age 5. If you haven't already, I encourage you again to go back and look at our other webinars for more information on the GELDS. You can access all of these informational webinars on our website, gelds.decal.ga.gov. Let me go over some structure and background of our GELDS. The GELDS are the result of an alignment study and revision project that began in 2010. Our goal was to improve the quality of Georgia's early learning programs with these early learning standards and provide a better alignment with our Common Core Georgia Performance Standards for K through 12. So we had the Georgia Early Learning Standards, the GELS, for birth to 3, and we also had the pre-K content standards. Well, now we have just one set of standards that are research-based and aligned for birth to 5. Just as a review, let's go over our GELDS structure. We all know the GELDS have 5 domains of learning, the first of which is physical development and motor skills. And under that one, we have our health and well-being, our use of senses, and our fine and gross motor skills. The second domain is our social and emotional development. And under this one, we've got developing a sense of self, self-regulation, and developing a sense of self with others, those important social skills with peers and social skills with adults. The third area of learning, or learning domain, is our approaches to play and learning domain. And under that one, you've got your initiative and exploration, your attentiveness and persistence, and of course, you've got your play. The fourth learning domain is communication, language, and literacy. And under that one, we've got our receptive language, those listening skills. We've got expressive language, early reading, and early writing. And finally, we've got our cognitive development. And under this domain, you've got 5 subdomains. So this one's a little bit different. You've got your math, your social studies, your science, your creative development, and then lastly, those cognitive processes, which are those higher order thinking skills and those problem solving skills. The last thing I want to do before we get started is go over how the GELDS will be coded. And remember, today we're only focusing on science. The GELDS coding looks something like this. So you've got your learning domain first, and for this one we're focusing on science, which is SC. And then next you've got your standard number, and for this example we're talking about science standard number 5. And then next you've got your age. So this will be a number 0 to 4 to tell us which age this indicator should be addressed. The last character is your lowercase letter, which tells us which indicator we're talking about. Let's get started with science. And remember, we're breaking this down today and only covering one specific area, and that is science. And our first strand in science, Dr. Laura, is scientific skills and methods. And under that strand, you have standard SC1. The child will demonstrate scientific inquiry skills. And then under that, you have your age-appropriate indicators, where with this, at 0 to 12, they're going to start off just observing and exploring objects using their senses. And that skill builds and builds and builds and builds until you get to 48 to 60 months, where they're using their senses to observe, classify, and learn about objects and the environment. Why is this such an important skill set for children?
Well, all children form hypotheses. All children ask questions, and asking questions is what science is all about. So this is really important because I want, especially infant toddler teachers, to recognize that this specific domain and indicator around science is really important, that we need to allow children to ask questions. We need to allow infants to tilt their head and open up their eyes, which is a question for them, and teachers need to respond with information. And the idea of engaging our senses just means that children can be active in their learning, and the more active they are as part of the learning process, the more they actually learn.
Okay. We're going to take a look at a clip in just a second, but first I want to look back at the slide that I just had up. Under this, the child will demonstrate scientific inquiry skills. If you look under SC 1.3A, uses senses to observe and experience objects and environment, and then under that you have another indicator, 3D, participates in simple experiments and discusses scientific properties. Now, as we watch this next clip, I want you to think about those two indicators and how this teacher addresses those indicators with this activity. Let's take a look.
Basically what I did was took some baking soda and some vinegar, and we had to put the vinegar on top of the baking soda, and they saw it fizz up. If I had enough in, then it came over the cup, and you know, they was able to see it. And then we talked about what it smelled like, because we know the vinegar doesn't smell that pleasant. We talked about, you know, whether or not we eat the activity that we were doing, because so often when you give children something, you know, is baking soda okay? My mom used baking soda in her cooking, so let me taste it. So we explained, you do not eat this because this is the activity that we're doing. This is called baking soda. And sometimes your mommy cooked with baking soda, but today we're not going to cook with the baking soda. Are we going to put it in our mouths?
No.
No. What will happen? What will happen if we eat it?
You get sick.
We're probably going to get sick. That is correct. You got your eyes ready? You sure?
Yes.
Watch what happens when I'm going to have to do this. Look. And if I stir it up and put some more, what does this smell like? Oh, look at that. Are you ready to do yours?
Yes.
Stir it up. Hold on to it. Stir it up. I need yours to be sitting flat for me, sweetie. Stir it up. Here you go. Whoa. Bubbles. Just to see the bubbles come over the cup. The children really had fun with it. And in turn, they decided to go a little further with the activity. I just initiated one little part of it. So I think they enjoyed that.
I love that clip. So many skills in that clip. What were some things you noticed?
Well, I love the way that she says, what would happen? Because that's all about science. What would happen? What is the hypothesis? I love the way she said, look. Take a minute to look, and then the children became very involved. And I also like the fact that she made sure she had enough materials so that every child could participate. I think it's really important that we also take this activity and think about how could we adapt this activity or this type of activity to an infant toddler classroom. So certainly baking soda and vinegar would be things we don't want children to put in their mouth at this young age. So perhaps we could put an ice cube tray in the freezer and maybe put a maraschino cherry in each ice cube. And when it comes out, put those ice cubes on the table in front of infants and have them move those ice cubes around the table. And we can talk about, look at what's happening to the ice cubes. And then after a couple minutes, oh, they're gone. Where did the ice cubes go? So we really can engage our senses, observe, and really think about objects in the environment. For both infants and toddlers, we just want to make sure we're using materials that can immediately go into their hands, or food or things that can go in their mouth.
She also brought some cause and effect into the conversation. What happens if you eat it?
Absolutely.
You get sick. I
Right.
liked that.
She was great.
Yeah. Okay, let's move right along with our strand, scientific skills and methods. Also under this standard, SC1, which is the child will demonstrate scientific inquiry skills, you have another set of indicators. Remember, there's many indicators underneath all of these standards. Indicator B is about tools. So at 0 to 12 months, the infant is just attempting to use simple tools. And then as they move along, they're using simple tools to explore, they're using simple tools through play, using tools to experiment and observe, and then finally at 48 to 60, they're using tools correctly to experiment, observe, and increase understanding. I want to take a look at this clip. This is a science experiment using a tool and earthworms. Let's take a look.
One child, she has an interest in insects, worms, bugs, anything in the insect world. So what I do with her is I take and I incorporate that in my lesson plans. I incorporate it into science. I bring the bugs in, live worms for her, live bugs, whatever is out during that particular season. If it's the summertime, I use the butterflies. If it's wintertime, I use, like right now, she played with earthworms. What does a magnifying glass do? It makes it look what? Bigger or smaller? Which one?
It's bigger.
It's bigger. It makes it look bigger. And what are those inside of there? You have what?
Worms.
What kind of worms? They're called what? Earthworms.
You want it?
Yes? You have earthworms. Can you show? Hold it up and let me see him. I can't see. I need my glasses. Can you grab the earthworm for me? Pick up the big one.
The big one start with Thomas Day.
Yes? Can you hold him up so I can see him? Is he long?
One is long.
One is long and one is what? Short. Look at that. Which one is the mummy?
This is mommy.
And which one is the baby?
This is a baby.
That's the baby one? Yes?
You want to smell?
You see? Hold your magnifying glass. I gotta get one too so I can see it. Oh my goodness, look at that. Isn't he? Oh my
Sit
God.
it down.
Yes? And that's how you do it? You sit it down on it? She enjoys the earthworms right now. So I just take and build upon that.
Let's talk a little bit more about this progression of skill, because I know a lot of infant toddler teachers would say we can't use scientific tools in our classroom, but we're talking about a progression of a skill. So how would that start off? What would be the basis of building that skill?
So many of us have seen very young infants reach for their pacifier and put it to their mouth. And that pacifier in that moment becomes a tool. But let's talk about spoons. Because a lot of times when we have infants who are able to sit up in their chair at the table, they'll hold a spoon in their hand and then they'll eat with their fingers. That's giving them the first opportunity to interact with this important tool that they're going to be using for the rest of their lives. So this first strand is, hey, just hand them the tool. Let them get used to holding the tool. And then when you move on to toddlerhood, how do we actually take this tool and use it to feed ourselves? And then by the time a child is moving into that 36th month, they're using that tool successfully. So when we think about the word tool, the tool is anything the child is using to create a cause and effect reaction.
Okay, you mentioned the spoons. Let's watch how one teacher is helping progress that skill.
Gonna go ahead and eat it, Brayden? You thinking about it? Go ahead and eat it. It's okay. I'm right here. Here, Calvin. There you go. Here's your spoon.
I'm sorry, I have to undo some of your decorations.
Why don't you try using the other part of the other side of the spoon? Let's use this other side of the spoon. Let me help you out. Let's put it inside. Open mouth. There you go, Brayden. There you go. Good job, Bray. Let's try it again. You try it, Brayden. You want to use your tool? Are you using your tool?
What were some things that you noticed in that? They were using tools.
They were absolutely using tools. And the best part of that clip for me was the teacher scaffolding. So scaffolding is a word that means I'll be able to support you. I'll model for you to a limit that you need me to. So for one child, she literally had to put her hand over the child's hand and say, let's use this tool. For another child, all she had to do to model or scaffold was put the tool in front of them and say, use your spoon. So she really helped each child in an appropriate way. But her scaffolding was beautiful.
And I liked how she made the children feel so comfortable. She kept saying, it's okay, I'm here. Why is that so important with encouraging risk-taking with children?
So children love feedback, but children learn in the context of relationships. So the teacher must form a caring relationship so the teachers will trust her that whatever you're giving me is going to be safe for me to play with. So that's amazing that she was really reinforcing her relationship with those two lovely infants.
All right, well, let's move on from scientific inquiry and move on to our next strand in our science domain. This strand is Earth and Space. And your standard here, SC2, is the child will demonstrate knowledge related to the dynamic properties of Earth and sky. And if you look at our age-appropriate indicators there, so you're starting off with your 0 to 12 months with touching sand and mud with adult supervision and support. And then you're moving up through those age-appropriate indicators. You're asking questions about the properties of sand and mud and soil. You're investigating, you're exploring, and then beginning to describe properties of rocks, soil, and mud. So let's talk about that skill, Dr. Laura.
So the first thing is it's not about having children recite facts about mud and earth and sky. It's about children engaging with and having active play. So you really want to, especially in infant toddler classroom with that very first indicator, is really just allow them to have the experience of what does mud feel like. And what is the difference between what mud feels like and what sand feels like? And then as we move up the progression, now that I understand what they feel like and I'm not afraid to play with them, what does it mean when I put sand in a mold and create a mold because I've added a little bit of water? So you really want the children to see that these things that I'm exploring, these dynamic properties, change in different ways depending on how I'm interacting with them. So don't be afraid to let the children get dirty with this particular indicator.
Okay, and then moving right along with this strand, Earth and Space, you have another standard, SC3. And this one is the child will demonstrate knowledge related to weather and climate. And here with your indicators, you're starting off at 0 to 12 months observing different types of weather, pretty easy for an infant teacher to do. Then you're using emerging vocabulary to describe basic weather. Then you're discussing weather, then you're observing and discussing changes in weather, and then finally at 48 to 60 months, you're using appropriate vocabulary to discuss changes in weather and climate. So you want to talk a little bit about how a teacher can address that?
So that key word that you said, appropriate. So it's one thing for a child to say, oh, it's cloudy outside. It's another for a child to say, it's cloudy outside, so I don't need sunglasses. That's using cloudy in an appropriate way. So teachers should at a very young age expose children to weather and climate. They should take infants outside when it's raining and let them feel rain. When it's windy, they should talk about, ooh, what did you feel against your cheek? Children should absolutely crumple fall leaves and talk about the weather in the fall time. And then we should again add the vocabulary to go along with weather and climate skills so that children start appropriately using that language.
It's very important. Our next strand in the science domain is living creatures. And if you take a look at the slide here, you've got standard SC4, and this is the child will demonstrate knowledge related to living things in his or her environment. We start off here with SCC 4.0a, just showing curiosity about people, plants, and animals. Then children start interacting with plants and animals, then investigating plants and animals and how they grow and change. And then at 36 to 48, they're observing and exploring a variety of plants and animals and their environments and life cycles. And then finally at 48 to 60 months, they're observing, exploring, describing a variety of plants and animals and their basic needs. One thing I want to point out on this slide, and with all of the science indicators, you notice the verbs in these indicators. And this is a good chance, I know you and I both are big fans of Bloom's taxonomy, building those verbs and letting the verbs indicate the higher order thinking skill that you want to address. So you want to talk a little bit about the importance of that?
So the importance of verbs is that it represents an active involvement in the learning, an active involvement with the activity. So verbs help that remind the teacher that a child needs to be doing something in order to be learning. So teachers should always think about, is this something that a child is just passively watching, or are they able to do something? And can I watch them engage in this activity and be able to tell what they're learning by the verb that's being used?
Okay. And while we're on living creatures, here's a good clip of children really doing something with plants and animals. The teacher's giving the children plenty of opportunity to explore living things, plants, and a fish. Let's take a look.
I believe that children need to learn about living things because it teaches them so many things about empathy. It teaches about the natural processes of how we grow, how we develop. It also teaches us that we have to take care of things that are living. If we don't provide the plant with the water or the sunlight, the plant's going to die.
We're going to water our plants because our plants need to have water in order to grow. Remember, they were just a little bitty sprout when we put them in the dirt. Remember that? They were just a little sprout.
My turn.
We're gonna have a turn in just a minute. So today they need to be watered. That way they will grow. Because water helps them to grow. They get thirsty. You remember how we get thirsty when we're outside playing? Well, our plants, they get thirsty too. And when they get thirsty, we have to give them water. So do you think you could water a plant for me? Janiyah, could you help water a plant? Can you girls water a plant? Water it together. Mine. Mine. You can help Kate and Kat, okay? Kaden, you give it a little bit of water, and then let Marlena give it a little bit of water. Did you give it all the water?
Yep.
And it absorbed all the water, right?
Yeah.
All the water went into the plant. We don't want to overfeed our fish because he might get full.
Is he going? Hey.
Let's watch and see. Let's watch and see. I see him way down here. I wonder if he's going to come up and get some fish food. Let's watch him. Here he comes. Here he comes. He's coming to the top. He was at the bottom, and now he's coming to the top. He must smell that food. Do you think he's going to eat?
Yeah.
You do? Let's see. He's trying to pretend like he's attacking it. Did you see that? He ate that whole piece in one bite.
Are you kidding me?
Look, it's hanging out of his mouth. I'm not kidding you. It's hanging out of his mouth.
We all need things that are going to allow us to grow. And children need to learn that when they're young. That way they can carry those skills and that knowledge into adulthood.
Well, that is the absolute cutest little boy I've ever seen. But other than that, what are some things that you noticed that stood out about this activity with living creatures?
Well, so many things. Number one, I loved how she lifted language. She added the word absorb. I love how she really pulled language up. She used some directional language also. I also love how she made the connection. You know, the plant gets thirsty just like you do. So this isn't a topic that you don't understand because you all get thirsty. Of course the plant's going to get thirsty. So I just really loved her total involvement in that activity with the children. And she was right there really demonstrating an overlap of all the domains in her work.
And you know, those children were obviously older. What are some ways that the infant teachers could incorporate living creatures in the classroom?
Well, I certainly think that by 12 to 24 months, children can absolutely interact with plants by growing a garden. And you can start with an interior garden that's on your shelves, but you could also just do a whiskey barrel garden outside your classroom door. For even younger children that birth to 12 months, you can really just reinforce the child's natural curiosity. So if a child hears birds outside the window, it's your responsibility to walk them to the window and point out this is what you're hearing, so they understand that. So always, again, as soon as the child shows curiosity about the people or the plants or the animals, move towards that and really engage the child to get them go a little bit deeper in that content.
Okay. Awesome. Now let's move on to our next strand or area of learning under the science domain. We have physical science, and under this one you have standard SC5. The child will demonstrate knowledge related to physical science. Again, we have our age-appropriate indicators under every standard that tell you exactly when a child should be meeting certain skills. So at 0 to 12 months, you have demonstrating ability to just move objects. Very simple skill that progresses to demonstrating ability to push and pull objects, then exploring motions to play with toys with teacher support, then independently investigating objects and toys, and then exploring and describing position and movement of objects and toys. So before we talk about this a little bit more, I want to take a look at a RAMPS activity that I had the opportunity to witness and see how one teacher addresses physical science.
I think the skills that this activity, which was simple machines, the big thing is to listen. They had to listen to directions. They had to be patient, even though they were all anxious to get into doing, which is fine, but we have to do it safely. It is the inclines, the planes.
That's an evacuation route, I think. What do you think?
The kids really like it, and I could see their creativity by taking out additional things that I did not have out, the additional cars and some extra blocks and stuff, and they're talking to each other. Gosh, I'm making this, and can this go through?
Take our own cars.
It's an interaction, it's social, it's problem solving. There was a lot of things going on, and the children were very happy.
So to somebody from the outside, it kind of looked chaotic in that classroom. All sorts of materials all over the place, kids everywhere. But what was so great about that activity?
Every single child was engaged. Every single child was asking a question. What happens if I put the car up here? How do I have to move this pipe to make the car go that way? So the involvement of the children really getting involved in this physical science activity, something that you and I think about for high school students, was really important. And let's not forget, our infants and toddlers can be very involved with physical science. Think about toddlers who push chairs around the classroom. Drives a teacher crazy when they do that. That's physical science. I'm going to get this chair from this part of the room to the other part of the room. Most toddler teachers have little slides in their classroom, and they could put big balls on that slide and let those balls go down, and then let the children demonstrate how they can also make that successful. So don't ever be afraid to engage infants and toddlers in physical science. You just need to do it in an age-appropriate manner.
I completely agree. All right, last strand in our science domain, you have interaction with the environment. And this standard, SC6, says the child will demonstrate awareness of and the need to protect his or her environment. Under this standard, you again have your age-appropriate indicators. This skill starts off with identifying familiar people and or objects in his or her environment, then moves along to living things, and then with assistance at 2 years old, he or she participates in activities to protect the environment. Then at 36 to 48, participates in efforts to protect the environment. And then at 48 to 60, understands that people have an impact on the environment and participates in efforts to protect the environment. So we're talking about protecting the environment. It sounds like, you know, a high skill concept for children, but how can we do this?
So it's not just recycling. That's
Right.
the most important thing to remember.
Right.
For an infant, it's literally about, can I identify familiar people and objects in my environment? So for an infant, when they're able to move around and they're just starting their walking skills, can they go and find their cubby and bring you a diaper? That's understanding that this is my environment and there's a cubby and my materials are in the cubby. And then as we move through, for toddlerhood, we can do more and more about finding things in our environment and knowing where things are located in our environment. And then we can start thinking about protecting the environment. Ooh, where does the trash go? The trash goes in the trash can. Hey, do tin cans go in that trash can or do they go in the green trash can so we can make them into something else? So then we can start sorting by things that can be recycled. And then when they move into a preschool classroom, we can tell them, hey, you're recycling. When you sort those materials, now you're recycling. So it's just about building slowly and surely, so when a child moves into these much harder indicators, that they already have an idea of what they're doing. You're just going to give them the language for it.
Okay. Well, that's all in our science domain, but before we wrap up today, I want to take a look again at our diagram that helps teachers understand the connection between the Georgia Early Learning and Development Standards and curriculum and assessment. It's a good connection that we all need to be aware of as we're approaching our teaching strategies and our instructional strategies. So you always start with your Georgia Early Learning and Development Standards, and your standards help guide the decisions you make regarding your lesson planning and your assessment. And as far as your assessment goes, assessment can be observations, but your observations and assessments let you know if your children are meeting those standards and if you need to go back and possibly reteach some of those standards. So that's just a little demonstration of how those three components work together. I also encourage you to visit our new GELDS website. It's gelds.decal.ga.gov for more information, including a searchable database of all of our new GELDS. You can also find more of these webinars that we've done surrounding the GELDS, and you can find other resources that will help you with the implementation of the GELDS. Well, that's it for today. We are extremely excited about this rollout of our new Georgia Early Learning and Development Standards, and I want to thank Dr. Laura Johns for joining me once again to help get you the information you need. We will see you next time.